guys, okay, so last night my friend Jackson from Australia had called me and asked for a help. Recently, he has moved to a new house and wants to renovate a little bit to his house. He wants to add some window to his house. So he is a little bit confused to use whether a single pane window or double pane window. Which one is more better? So don't worry, my friend Luqman and I will try to help him, so stay tuned.
Alright, so first thing first that Jackson must know is the theoretical concept of the single pane window and double pane window. So basically, single pane window consists of single layer of glass, while double consists of two layers of glass. Basically, the installation of the single pane window is less and the double pane window is high due to it has some gases such as argon or krypton used in the window. However, the single pane window is less energy efficiency, which lead to the more spend of money to the heating and cooling bills, while the double pane window can save 20 to 30% annually energy bills because of the higher energy efficiency. It is good, right? Besides, single pane window is no insulation. When there is no insulation, the outside temperature and also the noise from the outside will easily heard from the inside of the building. However, double pane window consists of insulation barrier, which lead to the soundproof, will reduce the sound noise and more comfortable towards the people inside the building. Alright? So we move to the next part, which is how the windows works, how it functions. Basically, a glass window uses the concept of conduction, where the heat is passed through a solid material from molecule to molecule. And it is important you make the frame and the window from the glass. Just imagine you make the window from the plastic, it will be melt. If you make from the paper, it will be burned. If you make from the wood, the light cannot pass through. So what is the function of the window you make? So we use a glass as a medium for the solid material for the heat to pass through by conduction. So basically, conduction is driven by the temperature difference, where theoretically, when outside is warmer than inside, conduction will occur to the inside. Meanwhile, when the inside is warmer than outside, the conduction will occur to the outside. Okay, clear? So basically, the glass window uses the concept of conduction. Alright, so that's all. So, how to prove it?
Alright, for the proof, for the single pane window, the given info is here. We got the area, thickness, the coefficient, temperature. Then we need to find the individual resistance. So there's a window here, and then there's heat passes through here, and then we find for the R convection, R glass, R convection Q, and we got this answer. Next, we move to find the total resistance. Means that we sum up all these items inside here, so we get this value, 0.1127 degrees Celsius per watt, and then we need to find the steady rate of heat transfer. As you can see here, this is from the steady rate, the rate, and then we got the answer 2.66 watt. And then for the inner surface temperature, we reshuffle this formula, and then we got this temperature. So it is for single pane window. So low surface temperature, highly undesirable. Why? Because it can cause a formation of fog and frost when the humidity in the room is high.
Okay, so now I will pass to my friend Luqman to continue about the double pane window calculation, how to prove it. So I will pass to him, Luqman. I think that's all from me. Now I'll pass to Luqman.
So our friend Jason, who stay in Australia, is confused to choose either single pane or double pane window. And Danial has solved for the single pane window, and he asked me to do for the double pane window. Okay, I think I got it. So let's start for the calculation. And here we go. We have double pane window consisting of two 4-meter thick layers of glass with K 0.78 watt per meter Kelvin, surrounded by a 10mm wide stainless steel space with K is 0.026 watt per meter Kelvin. So we have to find the steady rate of heat transfer through this double pane window and the temperature of its inner surface T1 for a day which during the room is maintained at 20 degrees Celsius, while the temperature of the outdoor is negative 10 degrees Celsius. So we take the convection heat transfer coefficient on the inner and the outer surface of the window to be H1 equal to 10 watt per meter square Kelvin and H2 equals to 40 watt per meter square Kelvin. And this is our free body diagram. Okay, firstly, we have drawn the thermal for the diagram using the formula for R convection 1 over HA and R conduction L over KA. H is the convection coefficient, L is the length, K is the thermal conductivity, and A is the area. So we have to find the total resistance of the thermal circuit. We have about 5 resistors here, with R1 is R correction. Using the formula of R correction 1 over HA, we put the value that we have and we get 0.0833. Next, we find for the R1. R1 is equal to R3 because it is both plus and have the same dimension. So using the formula of R conduction and OKA, and we substitute the value and we get 0.0427 degrees Celsius per watt. R2 is RA using the formula of R conduction and OKA, and the length here is 0.01. Okay, make sure you know the length, the space between the two glasses, and the thermal conductivity is using the air value that we have obtained there, and times by the area, we get the value 0.3205 degrees Celsius. And lastly, for the convection at the outer surface, R convection using the formula of R convection 1 over HA, substitute the value and we get 0.2083. And the three resistors are in series, then we total all the resistance and we get 0.4332 degrees Celsius per watt. So we have calculated the total resistance of the circuit, and now we can find the rate of heat transfer using the formula Q equals to T infinity 1 minus T infinity 2 divided by the R total. We know that our T infinity 1 is 20 degrees Celsius and the outer temperature is negative 10 degrees Celsius. We substitute the value and we get 69.2 watts. For single plane that Danial have calculated, he got 266 watts. And for double plane, I calculated the value is 69.2 watts, which is about 1/4 of the result obtained in the single plane. The reason is because the drastic reduction of heat transfer rate in this case is due to the large thermal resistance of the air layer between the glasses. And then we have the rate of heat transfer, which is 69.2 watts. Using the same rate of heat transfer, I can find the surface temperature of T1 using the formula rate of heat equals to T infinity 1 minus T1 over R convection. Why R convection? Because the range of temperature is between T infinity 1 and T1, which is at the convection region. And we arrange the equation, we get T1 equals to T infinity 1 minus rate of heat transfer times R convection 1. And we insert the value, we get the final answer 14.2 degrees Celsius. For single plane, the value is negative 2.2 degrees Celsius, which is too low and easy to frost the window during the winter. And for double plane, it is better because it rarely gets fog, and in addition, it can reduce heat gain in summer. So yeah, we have come into the conclusion. Danial have calculated for the single plane window and I have calculated for the double plane window. And I suggest Jackson to choose for the double plane window because the temperature of its inner surface is considerably higher than the single plane window obtained in the previous calculation. So therefore, a double plane window will rarely get fog, and a double plane window will also reduce the heat gain in summer, thus reduce the air conditioning cost, which this choice will be better for Jackson. So Jackson, make sure you choose for the double plane window. And next, we move to the application of industry. Application of heat exchanger in industry. Okay. We are wondering how the big amount of food is being stored for some times. So we decided to choose the refrigeration system. Before that, let me give some brief definition of what is heat exchanger. A heat exchanger is an energy or heat exchange system between a hot and a cold fluid. So in refrigeration system, heat exchangers are essential elements. In refrigeration circuit, during cooling, heat exchangers are used as an evaporator to absorb energy from the refrigerant. On the other hand, during heating, heat exchangers are used as refrigerant condensers to discharge the energy. In some refrigeration cycles, depending on the application, it is necessary to superheat or supercool the refrigerant. Heat exchangers are also used in those cases. Okay, let me show you how it works. Okay. First, the refrigerant passes through a small turbine or through an expansion valve in this device. Work is done by the refrigerant, so its internal energy is lowered to a point where the temperature of the refrigerant is lower than that of the air in the refrigerator here. Okay, a heat exchanger is used to transfer energy from inside the refrigerator to the cold refrigerant. This lowers the internal energy of the inside and raises the internal energy of the refrigerant. Okay, now I'll continue to explain a little bit more on the heat exchanger in refrigeration. Alright, so first thing in a refrigerator, a refrigerant is needed. Okay, so the refrigerant first passes through a small turbine, and then in refrigerators, the refrigerant will lower its internal energy, until its temperature is lower than the air of the refrigerator.
Alright. Once the temperature is lower, the heat exchanger is then used to transfer the energy from the refrigerator to the refrigerant. Alright, and then the compressor adds energy to refrigerant. It'll continue adding energy to the refrigerant to increase its internal energy. Alright, so when the refrigerant is hot, when the refrigerant's temperature is hotter than the surrounding temperature, it is then passed through the heat exchanger to transfer energy from refrigerant to the surrounding temperature, making the air inside the fridge cool. So this is how a refrigerator stays cool. Alright, so first the refrigerant in the refrigerator gathers its energy, rising the temperature, and then it transfers to the surrounding temperature to keep the air inside cool. Alright, so after the transfer of energy, the refrigerant then repeats the cycle. Right, so this is basically how a refrigerator stays cool. Alright, and that is all. Okay, so we will move on to the question part of the topic to make it easier to understand how to make use of the calculation. Right, so in this question, as you can see, I have highlighted a few key data so that we can ease our way to calculate what the question wants. So the question wants to estimate the maximum capacity of the refrigeration plant required. Alright, so we have 15 tons of fish per day. We have initial temperature 10 degrees Celsius, final temperature of -8 degrees Celsius. We also have the heat transfer coefficient. We have the mean temperature drop, and we also have the specific heat of fish above freezing and below freezing, and also the latent heat. Alright, so first thing first is to find the enthalpy change in fish. Alright, so in order to find the enthalpy change in fish, it is equal to heat loss above freezing plus heat loss below freezing and plus latent heat. So we've highlighted, see, I've highlighted the key to make it easier, and then we just put in the numbers, and then we have the enthalpy change of 321.2 kilojoule per kilogram. And next, for the further calculation of these I will pass to Radzi.
Okay, to further the calculation, I will continue what Rafiq has done. Okay, to find the total heat removed in freezing, 15 times 1000 kg times with the enthalpy change, and got this. And then for the average rate of heat removal divided by 24 hours times 60 minutes times 60 seconds, so got 55.8 watt. And then stated there that maximum rate of heat extraction is twice average rate, so Q max equals to 2 times Q, so got 111.6 watt. Okay, for the formula is Q equal to UA delta T log mean temperature drop. So rearrange the equation to find the maximum capacity of the refrigeration plant required. We just substitute all the values there, and for the Q max we need to change into kilojoules since the heat coefficient is given in joule. So calculate that and got 420 meter squared. That's all for calculation.